Hello students, so today's class we'll continue with the numericals for classes. So this is the module 4, which is clutches and brakes. It's split into two parts again. So in this chapter we'll talk about different topics, that is clutches and gears. So once we finish with this clutches, we'll start with brakes, right? So clutches and brakes. This is the second numerical under clutches. So check this out. One numerical we solved yesterday. It was a single plate clutch, and this is the second numerical. Let's start off. So an oil immersed multi-disc clutch, which is with molded asbestos on one side and steel disc on the other side. So this is the data which will be required. So this data will be required. That is, what is the friction material and what is it up against. So the friction material, what is it butting against. So this data is required. And one more thing to note here is it's a multi-disc clutch. Okay, the previous problem which we solved was a single plate clutch, means there is only two contacting surfaces. That is one pair of contacting surfaces. But in multi-disc clutch, you can find number of pairs of contacting surfaces. So that's what we are set out to find. Let me note down this one by one. Okay, it's molded asbestos and steel. So this is problem number 2. So data is molded asbestos coupled with steel. Right. So we need to look this up in table 13.4 from the data handbook. The data handbook, I hope everyone have downloaded from edit, and the other is used in application. The torque transmitted by the clutch is 75 Newton meter. So torque transmitted is already given. Okay, so this becomes easy. So MT torque transmitted, that is this will be from the step 1. Okay, transmitted torque is always step 1. So this is already given. Instead of power, we already know this, so it becomes easier. Okay, Newton meter means we'll convert this into millimeters, into 1000, say Newton mm. Then the outer diameter of the friction lining is given as is kept as 100 mm to space limitation. So outer diameter is also given. So D naught or DO is outer diameter. DO is equal to 100 mm, and what else? Space limitation. The maximum torque transmission. For maximum torque transmission, take this di by d naught. So he's just giving the dimensions. Okay. Of action, and this is di over d naught equal to 0.577. So from this, now we can just find what is di. That is the inner diameter of the plate, right? So that will be 0.577 times 100 is equal to 57.7. We have the inner diameter. Let's go back to the question. Assume uniform wear theory. So similar to the previous numerical, assuming the uniform wear theory. So another convention which we can use is sometimes in the question, if there is mention of a new clutch, okay, a new clutch or a new vehicle. So that time you can use uniform pressure, because the no wear and tear would have taken place, and would run pretty equally. The pressure would be distributed equally along this plate surface. So therefore, what we can do somewhere, if it is mentioned in the question, if it is a new vehicle or a new automotive or a new clutch, no? So that time you can he won't mention which theory it is. Then automatically you assume it is a pressure theory. So this, you can say, when you are considering uniform wear theory, some wear and tear has already been taken place, as it is some old vehicle or some old machinery or old clutch even. So that time you use the uniform wear theory. So here is directly given. So therefore we'll just write uniform wear. We'll assume this uniform wear theory and determine only some main design parameters, dimensions for this clutch. So di naught are already known. The only thing we need to find is the mean diameter. Right. So most of the dimensions we have found out. So only thing we need to find is I'll write it down. So to find is two things. So this is a multiplate. One more thing we need to note on is this is a multiplate. The multiplate clutch. So that means we need to find the uh, number of plates. So I'll write n dash. So n dash is the number of n dash is the contacting surfaces, actually number of contacting surfaces. So n dash is number of contacting surfaces. Okay, so number of contacting surfaces, this is required to find, and I don't think any other dimension is required. Only the mean diameter will be required. That is dmw. This is mean diameter. This is pretty simple. Using, we just have to plug in the di and d naught. Okay, so two dimensions, two things are needed to be found. Okay, for this problem, this is the second numerical. So we'll start off. Now question is done. So solution. The first step. Step one is, I'll go back to the previous problem. So step one is torque to be transmitted. So this is required to be not found because already given. So torque transmitted already given. So we just copy paste this thing. So step one is nothing here. We'll move to step two. This is a shaft diameter. Let's copy this. Okay, one more thing we can do here, since there is no thing given. The material is not given. Material for the clutch is just mentioned some steel, but here this has to be given. Okay, tau permissible or the shear permissible shear stress has to be given. Okay, since this is not given, we'll just skip this. Okay, or we need to assume some material for shear stress. Anyway, this D we are not using anywhere. You would have seen in the previous numerical that this D, that is diameter of shaft, was not found, not used anywhere. But still, again, this depends on whatever material is given in the question for the plate. So depending on that, we'll just skip this. Let's move on. Step 3. We need to find the mean diameter of friction lining. I think I'll copy this also. Since it's the same wear theory, so the question states uniform wear theory. So therefore, what we can do, we can take the uniform wear theory, and it's pretty simple. It's the average of both of them. Right. So this is given in equation 13.9. F d naught here is 100 and 57.7. So this is 100 and this will be 57.7 over 2. So this will give us the mean diameter, is one key dimension, and the next is axial force needed. We can copy this since it's the same wear theory, right? So one by one we'll find out. So Pmax is maximum pressure. We'll get it from the table 13.7, right? Table 13.4. Sorry. So let's go back. Steps. Step 3. Oh, yeah, right. This is step 4. Right here. So given material was, what was the material? The molded asbestos steel. Let's see, search asbestos. Here there is no molded asbestos in here. So there is only woven asbestos and steel. So this is the only combination I can find. So there are two such combinations. Again, here we can choose either both of them, I guess. 13.4. Okay, these two. This is the only part. Okay, again here I think you can choose. You can choose. There is no molded asbestos. We can choose between these two. Let me check if this is the only part. Data handbook for this is the data handbook which is there in the edit. You just download this. I'm going for 13.4. So where is the no, it's not there. They are only molded asbestos with double star meaning for specific data. 5%. Okay, then doesn't matter. Only this much we are left out, but even then we are coming well within the range. So we can choose. Let's go back to the PPT itself. So we can choose the first one, which we used for the first numerical. Okay, so in this case, let's take wet. Let's assume that this is enclosed. Let's see what the question states. Okay, here, oil immersed. This data is also given. So oil immersed, meaning it is wet. Okay, it is given oil immersed multi-disc clutch. So therefore, if it is oil immersed, no, let's take it as a wet itself. Here. So woven asbestos, which is wet. So let's assume this as our coefficient of friction. And for maximum pressure, we'll use this data. 0.34 to 0.69. This is the same which we took in a previous problem. So this is 0.34 to 0.69. We'll make an average of this. So 0.34 plus 0.69 over 2. Just write 0.515. Not given, it's not minus. Okay, so this is from table 13.4. Okay, so this we have di, which is we have all the other data. We can directly go for substitution. Let me copy this. This is pi times Emax, that is 0.515, and di, which is 57.7, and d naught 100, and di again 57.7. So we'll get this FAW from this here. Let's calculate that. Let me know in the group chat. So right, that's about step 4. We'll move to the last step. The last step, torque to be transmitted, or torque transmission capacity. Torque transmission capacity, you get it from this equation. Okay, so we need mu here. Mu, I think I showed you in the previous slide. You'll get it from the table. So mu is 0.1 to 0.2, between 0.1 and 0.2 for wet. So since it is submerged, we are taking this condition for wet. Okay, so we are taking 0.1 to 0.2, 0.1 to 0.2. We'll take an average of this 0.15. Again, this is from table 13. Okay, and n dash is what is required to be found. How many number of contact surfaces are required? Okay, so FAW. Anybody found out FAW? Post in the group chat. Then DMW. I think you have found DMW. Oh yeah, that's also required to be found. Okay, let's see. 100 plus 57.7 over 78.85 mm. Let's calculate this. So we have phi, mu 0.15 into n dash, that is required to be found, into FAW, what we found out, 5 into 0.515 into 0.7 into 100 minus 5. Okay, so I'm getting is 1974.44 newtons. So FAW is 1974.44 into DMW. DMW is 78.85. 78.85. Right. So MT will be in terms of n dash. Let's calculate how much that is. 1974.44 into 78.85. So it is amounting to 11676.35 n dash. Right. So the last step, what you need to do here is now equate pairs of friction surface. You just need to find these just, from step 5, whatever we got here, empty plus from step 5 for design purpose. This should have been satisfied. Capacity and to be transmitted. So that means this is here. Torque, which we just found in step 5, should be greater than or equal to the torque to be transmitted. That was given directly in the questions. It was 75,000. 75,000. So, or n dash is the contact surfaces is equal to 75,000. Answer is reading 6.42. We got 6.42. Check once. Right. So this number of contact surfaces will usually be an odd number. We'll just approximate this to the next number 7. So 7 means um, how many plates you need. We can just split. There is a formula. So let's say n dash, which is a number of contacting surfaces, is equal to a plus b minus 1. So where a is your number of uh, plates which are installed in a multi-plate type of clutch. So this indicates number of um, plates, and B is number of friction surfaces. You can say number of hard plates. Hard plates is nothing but that of the steel, and this number of friction plates. Okay. So that minus 1. So that means we can A usually will be higher. 7 means we can have the number of hard plates, and 1 or 3, 4, and this can be um, 3, I guess. And 3, 7. This will be usually even, I think. Okay, about this formula, I'll tell you later. Okay, you can split it out like this: 4 hard plates and 3 friction plates. Whether you have 7 surfaces. Right. So that's about the second numerical. Any doubts here? If you check out how this plates thing works, I can show you. Okay, these are the plates, right? So outer disc, and so this is what I was talking about. So you have take for example this plate here. You have 1, 2, 3 plates. Okay, and you have 1, 2, 3. This is some what called an armature. It is equal in number. It is equal in number. The outer disc and inner disc, they are equal in number in this example. go to some other. To check it out here. I think here you can see clearly. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7. We have 8 plates. You can see these friction plates. There are 8 in numbers, and this hard plates. There are 7 in number. So we have 7 and 8. So in all the contacting surfaces will double for each plate. So let's say 1 here and 2 pairs of contacting surfaces. That's what we are talking about. Right. So let's move on to the next. So this is the last numerical for clutches. This is a multi-disc clutch. So this is also a multi-disc clutch. A multi-disc clutch consists of 5 chromium-plated hard plates and 4 hard-drawn phosphorus bronze plates. So he has given number of hard plates and friction plates, chromium-plated and bronze. So the inner and outer diameters of friction discs are 75 and 150. So let's note down one by one. The third problem, data given again multi-plate clutch. Multi-plate clutch with chromium plated and phosphor bronze. Chromium plated and phosphor bronze. Phosphor bronze. Then inner and outer diameter is given 75 and 150. Inner diameter. So let's say di and d inner and outer diameter in this case are given. Inner is 75, outer is 150. 75 and 150 mm. Okay. Then the consists of 5 chromium plated hard steel plates. So hard steel plates, let's take it as A is 5 and B as 4. Okay. Then and this clutch, can this clutch be used for application where power to be transmitted is 50 kilowatt? Power is given. It is asking us whether this can be used to transmit power 50 kilowatt at 1440 RPM. So N is given 1440 RPM. And the clutch is only to be used when it is new. Once it gets old, it has to be replaced by a new one. So here's the second clue. It is to be only used when it is new. So new means we need to take the consideration of uniform pressure theory, not the wear theory. So this only information will be given sometimes if it is if you need to consider the uniform pressure condition, right? So this means new directly means it's you need to consider uniform pressure condition. Okay. So solution will start off with step 1. Step 1 is this value here. Torque to be transmitted. We'll use this formula here. Okay, so power P equals this here by N. N is this 1440 times torque. Torque is what we need to find. This is 50. So from this we'll get what is the value of torque, mt. To find out, let me know in the group chat. Then we'll move on to step 2. Step 2 is diameter of shaft. Again, I think not required, and this data is not permissible. Shear stress is not given, neither is the yield stress given or the material. So we'll just skip that. So step 2 will be skipped. Skip since no info is given. Okay, we can move on to step 3, which is friction diagram. But here we can't use this formula because we are no longer following that uniform wear theory. We are now following the uniform pressure theory, right? For pressure, it is different. Go back to the presentation. Right. So we need to use this formula here for uniform pressure. Right. So it's a DMP. DMP. This is mean diameter for considering the uniform pressure. Okay. Torque is on 3. Right. This is Newton mm. It's not in mm, I guess. It's in meters. So that means once again, let's remove the point. So this will be in Newton mm. It's in meters, and we'll get it in. Right. So next fraction 2 by 3 into, say, another fraction. We have d naught cube d naught superscript cube and minus d naught, not d naught, di di. I'll just copy the whole thing. Do the numerator. Paste once again. So this will be square over n square. Right. So this is an unique equation 13.9c. This is 13.9c. So we have all the data here. So therefore, we can directly substitute and find out the value. So this is D naught is 150 75. This is 150 Ti 75 75. We can do the same here, 150, and this will be 75. Right. So from this we'll get what is the mean diameter of that friction lining is required. Calculate, post to the group chat, and step 3 is done. About step 4. So step 4, axial force needed to engage the clutch. Let's take axial force needed to engage the clutch. Again, here the formula is different. All right, we got 116.66. Approximate. Right, B. The axial force needed. Go back to the PPT. Axial force according to uniform pressure. Since there is a new clutch, we need to use this formula here. So FAP, uniform axial force pressure, is equal to fraction 1/4 into pi. That's fine. Pi times P, which is pressure, and close in brackets we have D naught minus Di squared here, squared here. Right. So this is according to equation 13.9a. 13.9a. Right. So only P is required to be found. Again, we need to go back to the data handbook. Go back to the data handbook. So the combination given here is what was the combination? Chromium plated and phosphor bronze. Let's see where it is. Chromium will be here. Chromium is here and here and here. Phosphor bronze here. Okay, nowhere else we can find phosphor bronze. This is the only combination here. It will be better in the PPT, I guess. Now you can check it out here. Chromium plated and hard steel, not hard steel, bronze, phosphorus bronze. Chromium plated and phosphorus bronze. For this, there is no dry, which means it should be wet and submerged. So mu can extract from here, and maximum pressure is 1.3. The maximum pressure for not for 1.3 for phosphor bronze and chromium plated steel, it is 0.98. Okay, for these two combination of the friction material and the opposing material, we have 0.98 P. So we'll use that. So P is 0.98 Newton per mm square. Right. So we got P, and that's all we need to find out everything else. So FAP, that is friction axial force, considering the uniform pressure, will be 0.98 times D naught 150 over Di is 75. Right. So that's it. So just calculate and tell me what is axial force considering this uniform pressure, and we move on to the next step. So we are at the last step, considering uniform pressure. Just some, only the notations are changed. So everything else been considered. Yeah, you're right. So the FAP, that is the axial pressure needed, is this much. You can eliminate some decimals. This much newtons. Right, you're right. That's the axial force needed, and for this you can see the only change is W becomes P. Okay, there's not much difference. The equation number, that's 13.9 C. Copy this from the previous one. Torque transmission capacity. So this is the torque transmission capacity, which is C, right? C, correct. So this W becomes P, and here W becomes P. Not much change there. Right? And mu also. And this data we have got it from table 13.4. Again, this mu is required to be found. Mu is, let's go back to the handbook. Mu considering wet conditions 0.03. So 0.03 coefficient of friction. Then for n dash, so n dash, in this case we have a formula that is a plus b minus 1. Okay, so that means it is these two, a and b, number of hard plates and number of friction plates. So 5 plus 4 minus 1 is 8. So 8 friction surfaces. Usually this number will be even. So in the previous problem only we got the number of friction plates, and that should have been an even number. Okay, next time whenever we are doing, we'll make it to an even number. So make that from 6.4, which we got in the previous problem, we'll make it to 8. Okay, similar to this. This is the actual formula to find number of friction surfaces, or vice versa. Want to find the number of plates and stuff. You can revisit that if you have any doubt. For now, let's finish this problem. So 0.03 times n is now 8 times FAP 12988.52 into TMP 116.66. Right. So from this we'll get the torque MT, that is transmitted torque. So I calculate this and let me know. We'll move on to the last step. So for design, this is our condition. Step, whatever we get for step 5 should be greater than or equal to step 1. Right. So okay, I'll just copy your answer. MT. So this is Newton mm. Now for our case here, this should be greater than or equal to whatever we got in step 1. This is step 1. Okay, so is this greater? So let me put some commas. I think it will be easier. Okay, it's not greater. Not greater or equal to any manner. So Therefore, what we can assume is the design is not safe. So let's go back to the question. What exactly is asked? Let's see. Okay, so was asked where power is transmitted this much. Can this clutch be used for application? That was the question. Can this clutch be used for application where power is to be transported? You can just say no. So you can say the design is unsafe, and the clutch cannot be used. That's it. Once you this did not satisfy, then you can just say it is unsafe. You cannot. That was the main thing which was asked in the question, right? So that's all you are required to find. Not supposed to. So suppose you want to rectify this. Okay, that means you need to increase this number here. What we have got in here. That means you need to increase the number of friction surfaces. But what the number of given surfaces is there is not sufficient. That is not sufficient. Either you need to reduce this, reduce the RPM, or reduce the power transmitted, increase the RPM or reduce the power transmitted. You need to lower this value, right? So if you want to lower this, you need to increase the RPM, or you need to decrease the power, or you need to increase the number of contact surfaces. That is the remedy which you can give if you are designing this particular. If it is unsafe, how do you make it safe? Increase the number of contact surfaces, and there are three other remedies you can suggest. Right? So for now, this will be enough, I guess, for a 10 marks problem. That's all you need to do. So any doubts you have on these two numericals? So with this, I think clutches are over. As plate clutches are done.